Good morning and afternoon, everyone. Welcome to today's webinar, Introduction to MemSQL. My name is Alicia, and I'll be your moderator today. Before we begin, there are a few housekeeping items I'd like to review. Today's webinar is being recorded, and you're currently in a listen-only mode. You may submit any questions you have throughout the webinar via the Q&A or chat function in the lower right corner of your console. We will address everyone's questions towards the end of today's presentation. After today's webinar, you will receive a follow-up email with a link to the recording and slides. If you wish to contact us, please send us an email to team@memsql.com. So let's begin. Today we'll cover common database and data management challenges that MemSQL addresses, as well as key differentiators between MemSQL and other databases out there. We will also walk through sample applications and customer case studies, and we'll close with an introductory demo. With that said, I'd like to introduce our speaker, Dominic Ravita. Dominic brings 23 years of experience across consulting, software development, architecture, and solution engineering leadership. He brings product knowledge and a senior technical perspective to field teams and customers. He has experience in distributed in-memory data grids, streaming analytics, integration, and data science. Thank you for joining us today, and welcome, Dominic. You now have the floor.
Thanks, Alicia. So, for those live listening and for those listening on demand, this is an introductory session that can serve as your guide to getting to know MemSQL, the technology, how it's used and the best use cases, and how to get started. So that's our agenda for the next 25 minutes. Modern data challenges abound everywhere. Businesses today need to find competitive advantages through harnessing this data. The challenge is doing this for both real-time and historical data when it's just a deluge of data across transactions and events. Coupled with the drop in the value of data over time, this presents a particular challenge. When you're looking at the data to take advantage of an opportunity, that can be fleeting if it's a customer experience scenario. If the stock item for an e-commerce store, say, is out of stock, that's a lost opportunity. If there's an opportunity to serve an ad at a particular time and it's the optimum ad or no ad at all is shown in that moment, it's a lost opportunity. But also opportunities to avoid threats or to identify emerging threats in terms of risk analysis is a common scenario. So when customers and businesses are looking at managing this data, they're looking to see what are the trends. Is this a new trend? Is this an extension of an existing scenario? Or is it totally novel? Also, what's the impact to the business for any scenario that's being looked at? And is the problem or the opportunity available in a particular region, or is it global? So these dimensions of data represent the modern data challenges. So at MemSQL, we think about these in three primary areas: speed, scale, and SQL. And starting with speed, shortening the time to insight is an important thing, to be able to proactively respond or to react to that change. So look ways that businesses can accelerate the time of insight. It's really important on vast amounts of fast moving or fast changing data. Secondly, being able to operate on all of the relevant data to determine the particular context. So the scale of data, the diversity of data is important to have the full business context. And so there's a technology underpinning that's required to be able to handle all of the data for the best and optimal decisions. And then finally, ease of access and simplicity of access provided by a familiar interface, which is structured query language, or SQL. In the past, the industry, we've had to use multiple different types of data stores to handle all of the data at speed and scale, and the trade-off was applications took on the complexity of handling join logic and such. With MemSQL, we bring the familiarity of SQL together with the speed and scale of NoSQL, and for all of this, we call this the database of now, built for operational analytics at scale. And so drilling down a little bit as to what are the characteristics of MemSQL, first and foremost, we're a scale-out general-purpose SQL database. And so we're distributed native. It's not sharding middleware placed on top of a single node database, which is a lot of cloud databases you see today. And the benefit of that is that we're much more efficient because we're purpose-built from the first line of code, from the storage level all the way up to how we do query optimization and query execution in a distributed cluster. Secondly, we provide flexible storage. And as I mentioned before, there's been a trend to use different purpose-built databases for different data types and different data access patterns. MemSQL embraces and synthesizes those and brings those patterns such as document-oriented style, key value, time series, geospatial, and brings in those as first-class citizens and native data types along with relational SQL traditional data types to give you a full converged solution. So it's flexible in storage in that way. Thirdly, it's responsive. So when you're looking for scenarios to where you need low latency queries, read and write queries, but also predictable and queries that you can trust that don't have a really high variance between invocations of that query. This is really important for customer experience. This is a great case for MemSQL, and so over hundreds of terabytes of fast changing data, MemSQL can provide, in many cases, single-digit consistent response times on those queries. Fourthly, it's familiar in terms of its SQL interface. It's an ANSI standard SQL that we support. And as you connect to MemSQL, you'll notice that it uses the MySQL wire protocol. That gives us huge access to any sort of language binding you'd want, from C, C++, Java to newer languages like Rust, Golang, etc. And it can be a drop-in replacement into your applications that may be using MySQL, but have now reached the point that they're no longer suitable for that functionality. MemSQL can be a drop-in replacement there as a distributed database. And then finally, MemSQL runs anywhere. It can run on-premise on bare metal, as well as in AWS, GCP, and Azure, and in containers and Kubernetes environments like Red Hat OpenShift, for example. And the punchline here is that, you know, MemSQL, in terms of speed and the cost performance ratio, is at a minimum 10 times faster and a third the cost of alternatives of traditional databases. And that's not just our own benchmarks that we've done, but also we see this validated again and again in customer environments. And this is pretty much the minimum kind of benefit you can expect for the kinds of operational analytics scenarios that I've described. So at a glance, who is MemSQL as a company? We're a very fast growing company, as you can see, both in terms of revenue, but also in terms of employee base and locations around the world. Our product is going on a decade of maturity now. We're in the current release of 7.1, and we uniquely provide this concept of single store, which I'll describe in just a moment. As far as our partner ecosystem, that's growing very fast. And as I said before, the public cloud partners are among our where MemSQL is available. So key use cases for MemSQL. First of all, operational analytics, which I've mentioned and I'll describe a little bit more here, is this combination of fast-moving data with analytic queries against it. And we like to say as a shorthand, when you have the need for analytics with an SLA, meaning that you need a response on analytical queries on operational data to help improve a customer experience, for instance, or gain better business operations insight. These are typical examples. I'll go through a couple of case studies in a moment that describes this. As far as Gartner and Forrester, they think about these areas in operational analytics as hybrid translytical processing that serve this kind of workload really well. And Forrester would call this translytical. Secondly, predictive and machine learning and AI. These use cases are served really well by MemSQL because machine learning models can be incorporated at multiple stages in the process. So during the training phase of a model, MemSQL provides really fast access to large sets of data. Especially if you're using something like a Spark environment or Python, you can directly connect and have very fast access for quick cycle time on the training phases. When you go to operationalize or put this model in production, that model can be used to score inbound transactions or data that's being ingested into MemSQL through MemSQL pipelines, which I'll describe a little bit more in a moment. Or MemSQL can call out through user-defined functions for models as part of its processing. And then finally, MemSQL is ideal for modernizing your data infrastructure in a move to the cloud or in a move to a hybrid environment where you want to augment some existing infrastructure as a step towards a cloud migration, or you want to accelerate a dashboard. MemSQL, it's not an all or none proposition. You can easily use the pattern of acceleration or augmentation through our change data capture capabilities. And so MemSQL does this for half the top retail banks and investment firms, 2 of the top telcos in the US, and across various other industries for these use cases of now or operational analytics. So let's go into the product a little bit here. MemSQL is a distributed general purpose SQL database. And it's not through sharding middleware, it's distributed native. What you see in the diagram here are the icons for in-memory row store and column store. So MemSQL provides both of these table types within a single database. And MemSQL is memory optimized, meaning that when data is ingested, it can be written to the in-memory row store as well as the column store, which also uses memory optimized structure as well as persistence on disk. MemSQL provides multiple ways to bring data in. Traditional bulk loads from file systems and object stores and data lakes are supported like Hadoop, but uniquely it provides a distributed parallel ingestion mechanism called MemSQL pipelines. And this can ingest data in parallel from streaming sources or cloud sources such as Spark and Kafka. And the benefit is it breaks the data bottleneck on ingestion that traditional databases have. The benefit to the user and for applications is that this further reduces the latency of the whole data process, but this sort of reduces latency at ingest time. Secondly, I've talked about the flexible storage of MemSQL, and part of what that is are the various data types that we support. And it's, of course, as a relational database, we support the typical types that you would expect there for varchars and strings and numerics, etc. But we treat geospatial, document, JSON, key value, time series also as first-class citizens and provide the data, the built-in functions to operate on those kinds of use cases. And it's important to note that you can combine these together. So a common use case is to write raw JSON, index that, query that in SQL, but then when you want to perform analytics on elements within the JSON, we have our compressed column store that helps to accelerate those kinds of analytic queries on that. Accessing MemSQL's data from common analytics tools and BI tools is very easy. As I said, We support the MySQL wire protocol. So any of your common tools for interactive ad hoc analytics with Looker or Tableau or Click, these are directly supported. If you're building dashboards out of Power BI, you can do that very easily. We've got content on our YouTube channel that describes and shows how each of these are done. And I've mentioned machine learning already. MemSQL is ideal to use not just for these sorts of analytic applications, but any sort of SaaS application. The simplicity it provides in combining both an OLTP and OLAP kinds of storage with row stores and column stores make it uniquely suitable for the kinds of workloads that we see in global SaaS applications with mobile interfaces for a global user set, APIs that are exposed from this, where they need very workloads such as fast key value lookup. You can use MemSQL directly for that with the in-memory row store. But if you're doing analytical queries on behalf of user interaction, again, the backing SaaS database or application database with MemSQL with the column store suits that really well. And we're available in all the public cloud environments, as I mentioned, the major ones, AWS, Azure, and GCP, but also on-premise with the binaries for as long as you have a Linux operating system, or in containers on other operating systems through Docker and Kubernetes, and in the cloud through distributions such as Red Hat OpenShift. So a little bit more detail on a single store. I mentioned that MemSQL provides both a row store for OLTP workloads and a column store for analytical workloads. We are on the path to providing the unification of these in a capability we call single store, such that at design time, the application designers, database designers no longer have to choose whether they choose their table to be created as a row store or their table to be created as a column store. Because what will be available is a single table type that supports both the OLTP or transaction types workloads, which are single lookups, typically lookups for small amounts of data, really high selective queries and filters, as well as large aggregations that you see in OLAP sorts of workloads where you're scanning billions of rows. That said, we'll provide both capabilities going forward, but by providing a default choice, will greatly simplify the application design process. And for most use cases, the single store or column store data type will provide the needed performance for OLTP and OLAP. I mentioned our capability for streaming and distributed parallel ingestion of data. And so this is a little bit more detail on that, and the capability is called MemSQL pipelines. And so it's common in cloud native architectures that your sources of data and your messaging bus or data distribution mechanism is a distributed service such as Kafka or Pulsar, or you've got distributed objects across object stores. So MemSQL pipelines allow you to do this easily with a single SQL statement. You create a pipeline object in MemSQL. It connects to these external distributed sources, either on-premise or in the cloud. And for every partition of the source and the distributed source, those line up to connections in the distributed MemSQL cluster. And each of those connections then pull or bring in data as it's written to those sources. And the benefit is massively parallel ingestion, which breaks the typical bottleneck for data loading. That reduces the latency significantly. So as you bring in data, you can write these to stored procedures if there are additional operations to perform, or write them directly into MemSQL tables for immediate querying. When this data is written to the table, it's then committed, and MemSQL can perform multiple processing steps that typically you might have done in external middleware here. So you can think of MemSQL not just as a place to store and query, but a place to process. It's a compute cluster as well as a storage cluster. So MemSQL runs everywhere. We provide this on AWS and GCP and Azure through a cloud database we call Helios. You can spin up clusters very quickly. I'll point you to that in a moment. But also you can, through the Red Hat Marketplace, for instance, get MemSQL through Red Hat OpenShift. We provide a Kubernetes operator that allows you to operate in those environments. So what are MemSQL's unique advantages? As I said, we're a distributed native database, and so we provide scalable relational SQL, which may sound like an oxymoron depending on your experience with different databases, but this is one of the unique innovations that MemSQL provides, which is the speed and scale of NoSQL, but with ANSI SQL semantics and ACID compliance. We're an immediately consistent database, which means that you don't get dirty reads. If you write data, it's committed, you get correct reads on that data, as opposed to an eventually consistent database like Cassandra or other examples. So this makes MemSQL ideal for an application database, also for analytics and operational analytics workloads. Secondly, we provide converged data. So as I mentioned, we support multiple data types as first-class citizens besides the traditional relational data types. And then thirdly, we're optimized for real time, and there are multiple technologies and innovations that help us do this, from the parallelism that we provide at the chip level with AVX2 instructions and SIMD instructions, but also the sophistication of our tiered storage model using memory and non-volatile RAM or persistent memory as well, right down to SSDs and our bottomless capability, which is a project that's ongoing on the roadmap, which I encourage the audience to check out our blog, The Future is Bottomless, to read more about what that initiative is about. So let's cover a few use cases here. MemSQL in these 6 verticals has a really fast and growing presence. So I'll cover a few of these now. For real-time decision-making in financial services, MemSQL provides some unique advantages. And so top financial institutions have adopted MemSQL to power real-time customer dashboards. Examples include wealth management, portfolio analytics, risk analytics, as well as trading and matching engines and execution, such as derivative trading. In our MemSQL community, we recently did a conversation with a cryptocurrency exchange in Asia that's using MemSQL to provide fast access to backing their API to submit trades, as well as the data for the matching engine. And this allowed them to simplify their backend data infrastructure and reduce multiple tiers into a single tier with MemSQL. In media and communications, some common use cases MemSQL is used for are ad analytics, ad optimization, ad personalization, streaming media and quality analytics. And so top firms use MemSQL to provide, again, examples of what we would call operational analytics on their digital products. And those digital products can be the quality of the streaming video itself in terms of pixelation or dropped frames. That's obviously a customer experience concern and needs to be spotted as soon as possible. But as well as optimizing the ad slots in terms of ad serving, as well as ad pricing. Because MemSQL provides this really highly concurrent access with low latency and predictable query times on fast changing data, it's ideally suited to these sorts of use cases in media and communication. Moving on to a telecom example, and this is timely with the current pandemic. True Digital, who is the data and analytics arm of a major cellular provider in Southeast Asia, has used MemSQL to create a proactive response to the COVID-19 situation by using cell phone ping data, which is time series and location data that's anonymized, to in real time determine population densities. This helps to provide a proactive view of where gatherings are starting to grow across the country, and allows public health officials to send alerts for where those gatherings are starting to form to help reduce the potential viral hotspot or outbreaks going forward. So many of these solutions today you've read about are historical or looking in the rearview mirror. This is a novel idea that True Digital partnered with the Thai government to perform to proactively help prevent new outbreaks. And so with that, let's move on to an example of Helios in action. And what you're seeing here is an IoT demonstration of a smart meter application. And this is a Looker dashboard that has statistics, a real-time dashboard that's viewing smart meter readings as they're ingested. And what you're seeing now is that data being ingested at close to 1 million rows a second in some cases here. And this is, time series data, which is it's a meter, it's a location, a timestamp, and several different readings. That data gets ingested through MemSQL pipelines, and there are 3 pipelines you see here that correspond to Kafka topics, where we've modeled this machine, the sensor data, which are transformer reads from SCADA instruments, voltage reads, and advanced meter infrastructure, or AMI reads. And so as that data is ingested in parallel, MemSQL is performing analytic queries against that data, as well as transforming it, while the dashboard is refreshing these views. So what's unique here is that you can operate on this fast-moving data as it's ingested. And so MemSQL is ideal for this kind of IoT use case, which is another example of operational analytics. The benefit for utilities or energy providers or smart grid operators or smart city operators is that you have instantaneous views on that fast-moving IoT data. So with that, let's describe how you get started with MemSQL. As I mentioned before, we provide MemSQL as a cloud database or SaaS database as a service. That's called Helios. And you can get started there at the link on the left, memsql.com/Helios, with $250 in free credits. You can use those on Helios on Azure, Helios on AWS, Helios on GCP. The second way is if you like to get your hands right on the software and run it locally on your laptop, you can do that as well. That's memsql.com/download. You can download MemSQL cluster in a box, which comes as Docker images, and you can get started in less than 5 minutes. MemSQL is really easy to adopt. As I said, the next step after you were connect to Helios or download it would be to connect your application. And you'll find hundreds and hundreds of connectors because we use the MySQL wire protocol. So whatever language or environment you're in, you can directly connect to MemSQL with one of these. And after that, I'd say start building and start your learning pathway. And depending on how you want to learn, if you prefer to read documentation, you'll find that at docs.memsql.com, or interact in our MemSQL community in the forums, which is a second link. Or if you prefer to watch YouTube videos to describe and show how these steps are performed or understand what's possible with MemSQL, We have lots of different growing set of video content and playlists. And finally, when you're ready, we have free training available at training.memsql.com that helps you get deeper in each of these areas for designing and operating your applications on MemSQL. With that, I'd offer the viewers here to join the MemSQL community to get alerted of other events that are happening in our community on a weekly and monthly basis. We do a weekly developer live stream every Friday at 11 a.m. Pacific. We also provide periodic Ask Me Anything sessions with our engineering and product management leadership. And we're growing the list of events for that. So sign up for our community newsletter at the MemSQL Community Hub on the website and start building. So with that, I'll open it up for questions.
Great, thanks, Dominic. So we'll now begin the Q&A portion of today's webinar. As a reminder, you may submit questions through the Q&A function located in the lower right side of your console. So some questions have already come in. We can start with this one. How do you differentiate between DB2 and MemSQL databases with respect to row and column stores, procedural programming, in parentheses, procedures, triggers, etc., and pros and cons?
Sure, that's a good question. DB2 is a database that's been around for decades, and it does provide an addition or a particular version of the database that provides both row and column data. How MemSQL is different than that or others like SAP HANA that provides a dual store, as we'd say, is that in those examples, first of all, they're with DB2, it's a separate edition. So it's really very much like a separate product. With MemSQL, this is just part of out-of-the-box functionality. And that makes it simpler when you're using MemSQL. Secondly, these other types of dual stores often require expensive proprietary hardware to get the performance that they're touting. MemSQL is designed on modern hardware from the very beginning, and so we have the advantage in our 9 years of development to be operating in an environment on first we built it distributed native from the start, and we're able to take advantage of modern hardware such as AVX2 instructions and chips, SIMD, etc. And so these are the two major ways I'd say that MemSQL differs from other types of dual stores like that. As far as procedures, MemSQL does support stored procedures and the common built-in functions of a traditional single node database we support in our distributed SQL database.
Awesome, great, thanks. Another question, we need unlimited time-free practice MemSQL environment, i.e. cluster in a box, which can be installed on home desktops or laptops with limited capacity with multiple other softwares running. This way we can learn this like any other databases like DB2, Oracle, etc. Is that available?
Yes, that is available. As the questioner posed, we provide MemSQL cluster in a box, which is the Docker distribution, or you can get the raw binaries and install MemSQL on your laptop. There is no time limit. There is no feature constraint on that. There is a capacity limit though, but it allows everything that the questioner was posing there in terms of development, and there's quite a lot of tutorials and documentation and videos that help you get started with the MemSQL cluster in a box.
Great. Can it work as a time series database?
Absolutely, and it can do more than just your typical time series database. So we provide native data types for time series and importantly built-in functions that are common for time series calculations. An example of that would be time bucketing, where you're trying to smooth a time series set of data into discrete buckets. Actually, these are two different things, but time bucketing and smoothing are two common functions on time series data. Those are built in with MemSQL. But importantly, you can combine those types of computations or calculations with traditional relational functions that you have in MemSQL. So in financial services, this is really common. People use MemSQL in lieu of traditional databases in financial services such as KDB Plus, or if they're trying to do really fast transactional lookups, things like Redis, MemSQL can replace both of those examples and provide you the time series functionality along with the benefits of highly compressed column store and row store for high-speed analytics.
Great. We have time for one more question. Can we limit the amount of data cached in row store or make it dynamic with frequently queried data instead of caching all?
So with MemSQL, it obviates the need to design a separate caching tier, which I think gets to that question a little bit. Because you can do workloads that are thought of as key value fetches, which are typical sort of caching use cases, and used by applications to speed up access to commonly used data. With MemSQL, there's often no need to have that separate data tier of a caching layer. And you can perform those workloads of those fast key value lookups along with your transactions and analytical queries, all of those workloads in MemSQL. The benefit is simplicity. You have fewer parts to manage in your application and data infrastructure architecture. You also, second benefit is you have less latency because there's no movement between two different data stores. And thirdly, well, you reduce the need to create logic on, when you evict the cache and things like that.
Great. Well, thank you everyone for all of your questions. Unfortunately, that's all the time we have for today. So for those of you with questions we didn't get a chance to address, we can follow up with you directly. I want to thank Dominic and each of you for attending today. Just a reminder, we'll be sending you a follow-up email with a link to today's recording and slides. If you have any questions in the future, you can send an email to team@memsql.com. We invite you to learn more about MemSQL at memsql.com or get started for free today at memsql.com/download. Again, thanks for participating and have a great remainder of your days. Bye, everyone.